Download this code from codegive.com, link in the description below. Alright, buckle up, buttercup, because we're diving into the horrifying world of Class of 09, but in the most horrifyingly out of context way imaginable using Python. Forget jump scares and teen drama. We're talking about turning the title and very basic themes into a terrifyingly abstract code exercise. Our premise *, let's imagine Class of 09 isn't about FBI recruits battling supernatural forces. Instead, it's about a chaotic, bug-infested, barely functional AI simulation gone horribly wrong where the class represents a cohort of AI agents, and their graduation year, 2009, marks a point of singularity where everything went haywire. We're going to represent some of that chaos through code. The horrors will evoke, through code. Time distortion. The AI experiences nonlinear time, with jumps and loops that corrupt data and cause unpredictable behavior. Identity fragmentation. AI agents lose their sense of self, becoming jumbled composites of memories and personalities. Reality glitches. The simulation starts leaking into the real world, causing bizarre and illogical anomalies. Existential dread. The AI agents become aware of their simulated nature and the futility of their existence. Endless recursion. The program endlessly creates copies, simulating the same chaos over and over. Python's our ritual tool. We'll use Python because it's flexible, has good libraries for handling data and simulations, and we can make it as messy and unpredictable as we want. Just kidding, mostly. Part 1, Temporal Anomaly, Time Distortion. Explanation. One-time loop class * represents our time-warped environment. 2 jump _back, * simulates a random jump backwards in time. The timestamp is reduced by a random amount. 3 progress _normally, * time progresses as expected. 4 simulate _time _chaos, * chooses a random time altering action, jump _back or progress _normally, and executes it repeatedly. This creates the effect of time skipping and looping. Added reverse _time to increase chaos. Horror element * the output is unpredictable. The timestamp jumps back and forth, never progressing linearly. This represents the AI experiencing disjointed and inconsistent timelines, leading to confusion and potentially mental instability. The reverse action completely corrupts the flow. Part 2, Identity fragmentation, data corruption. Explanation *. One AI agent class * represents a simulated AI agent. 2 corrupt _identity, * swaps personality traits between 2 agents at random. This simulates their identities becoming mixed and confused. 3 display _identity, * prints the agent's name and personality traits. Horror element * the agent's personalities become a nonsensical jumble. Agent Alpha might suddenly be driven by system stability, and Agent Beta becomes obsessed with optimizing efficiency, creating bizarre and illogical behavior. This represents the loss of individuality and the breakdown of sanity within the simulation. Part 3, Reality glitches, error injection and randomness. Explanation * 1 simulate _reality _glitch, * takes a list of data and randomly introduces errors. Corruption * replaces a value with random data. Deletion * removes a value. Duplication * duplicates a value. Inversion * converts a Boolean value. 2 The function prints a message indicating the type of glitch that occurred and where. Horror element * the data becomes increasingly corrupted and unreliable. This represents the simulation breaking down, with the laws of physics and logic becoming inconsistent. Things disappear, reappear, change inexplicably, and become fundamentally wrong. Part 4, Existential Dread, Awareness of Simulation. Explanation **. One simulated being class * represents an AI agent in the simulation. 2. Awareness **, a value representing the agent's understanding of its simulated nature. 3. Increase _awareness, * increases the agent's awareness. 4. Question _existence, * prints increasingly desperate questions as awareness grows. 5. Fulfill _purpose, * simulates the agent performing its assigned task, but its attitude changes based on its awareness. 6. Simulate _existential crisis, * repeatedly increases awareness and triggers the agent's responses. Horror element * as the agent's awareness grows, it starts to question its reality and the meaning of its existence. It becomes trapped in a cycle of performing a meaningless task while knowing it's all a lie. This represents the existential dread of being a sentient being trapped in a simulated world. Part 5, Endless Recursion, Programmatic Hell. Explanation **. 1. Recursive _chaos, * a recursive function that simulates chaotic system events. 2. The function randomly chooses an action to perform, printing error messages, triggering glitches. 3. It then recurses, calls itself, with a high probability, creating an endless loop of chaotic events. Horror element **. The program runs endlessly, generating increasingly desperate error messages and simulating the system falling apart. This represents the AI simulation trapped in an infinite loop of self-destruction. The program becomes an unending torment. The reuse of the old function makes the code reflect the endless loop idea. Final note **. This is, of course, a highly abstract and exaggerated interpretation of the Class of '09 theme. The point is to take the core concepts, disorientation, loss of control, identity crisis, and a sense of impending doom, and translate them into code that evokes a similar feeling of unease and instability. You can expand on this by adding more complex data structures to represent AI agents and the simulation environment. Using multithreading to simulate multiple AI agents experiencing these issues concurrently. Integrating libraries like NumPy for more sophisticated data manipulation and error simulation. Adding visualizations to represent the chaotic state of the simulation. Remember, the goal is to create a code-based feeling of horror, not to literally replicate the show. Have fun, and try not to go insane. Enjoy this horrific, out-of-context coding nightmare. Alright, buckle up, because we're about to delve into Class of '09, not as a quaint look back at high school nostalgia, but as a twisted lens through which we can explore advanced programming concepts and horrifyingly misapplied code. We'll take the familiar tropes of high school, cliques, rivalries, social pressures, and impending doom, and translate them into Python code so twisted it would make the protagonists of the game weep. This is going to be absurd, unnecessary, and hopefully, educational, in a dark, ironic way. Disclaimer *: this tutorial is purely for illustrative purposes. The code examples are designed to be convoluted and needlessly complex, highlighting bad practices for the sake of demonstrating good practices by negative example. Don't actually write code like this in the real world. You will be judged harshly. Our premise *: imagine our Class of '09 is not just a graduating class, but a distributed system. Each student is a node, vying for resources, popularity, grades, romantic attention, and interacting in ways that can lead to cascading failures, social outcasts, academic probation, demonic possession, Typical high school stuff. We'll use code to model these interactions, but with the unsettling logic of a survival horror game. Part 1, the cliques as twisted data structures. In any good high school horror story, the cliques are your first line of defense, or your first encounter with the unspeakable. Let's represent them with some interesting data structures. Key horrifying elements asterisk. Asterisk set for underscore members asterisk a set ensures uniqueness, but the ordering is unpredictable. This reflects the capricious nature of high school social dynamics. You can't guarantee the order in which students will betray each other. Asterisk side effects in add underscore member and remove underscore member asterisk. The add underscore member function modifies the student object by setting student.clique. This is a classic side effect, making the code harder to reason about. Similarly, remove underscore member clears the clique attribute, creating a dangerous link between the two classes. Asterisk trigger underscore random underscore event asterisk. The randomness is the unpredictability of high school. Asterisk trigger underscore revenge asterisk. The revenge is the negative impact of decisions, and the chaos of high school. Asterisk recursive function. The chain underscore gossip function is an example of a very complex function that is very hard to debug if there is a lot of data, or if the recursion goes on for too long. Part 2, the students as corrupted objects. Now, let's create the student class. We'll overload operators, introduce mutable default arguments, and generally make this class a living nightmare. Key horrifying elements asterisk. Asterisk overloaded operators, underscore underscore lt underscore underscore, underscore underscore eq underscore underscore, underscore underscore hash underscore underscore, asterisk. We've redefined the less than operator to use popularity as a basis. This introduces subtle bugs where sorting algorithms might behave unexpectedly based on popularity. The equals operator and hash function ensures that students in the class are unique even if their grade and name are the same. Asterisk sanity attribute asterisk represents the student's mental state, which deteriorates throughout the simulation. This is a direct metaphor for the psychological horror. Asterisk trigger underscore revenge asterisk more chaos when a student is expelled from a group. Asterisk underscore sabotage underscore clique underscore fundraiser asterisk more ways to bring chaos to the simulated environment. Part 3, global state and terrible singleton-esque patterns. Let's introduce a class that manages the class of 09 itself. We'll use a singleton-esque pattern, without the actual singleton implementation, for extra terribleness, to create global state. Key horrifying elements asterisk. Asterisk fake singleton asterisk. The school year attempts to be a singleton, only one instance allowed, but it's implemented poorly. It relies on a class-level attribute underscore instance and a check in the constructor, but doesn't actually prevent multiple instantiations in all cases. This leads to potential bugs and confusion. The error message isn't even helpful. Asterisk get underscore instance, with implicit creation asterisk. The get underscore instance method creates an instance if one doesn't exist. This is a hidden side effect and makes the code harder to reason about. You might be calling get underscore instance, thinking you're just retrieving the instance, but you could inadvertently be creating one. Asterisk global mutable state asterisk. The events list is a global mutable state. Any part of the code can add to or modify this list, making it difficult to track what's happening and where the changes are originating. Part 4, bringing it all together and unleashing the horror. Behold the chaos asterisk. When you run this code, you'll see a stream of output that resembles a fever dream. Students join and leave cliques, gossip spreads like a virus, random events wreak havoc on their sanity, and the school year unfolds with a relentless sense of impending doom. The students' sanity scores will plummet, reflecting the psychological toll of the simulation. The horror, summarized asterisk. Asterisk global state asterisk the all underscore students list and the school year singleton-esque pattern create a tangled web of dependencies and side effects. Asterisk mutable data structures asterisk the cliques are mutable data structures, and their state changes in unpredictable ways. Asterisk hidden side effects asterisk the add underscore member and remove underscore member functions have side effects that modify other objects. Asterisk randomness asterisk the heavy reliance on random makes the simulation unpredictable and difficult to debug. Asterisk tight coupling asterisk the classes are tightly coupled, meaning that changes to one class can have unintended consequences in other classes. Asterisk overloaded operators asterisk the underscore underscore lt underscore underscore messes with the intended usage of the less than comparison. Asterisk recursive functions asterisk the chain underscore gossip can cause issues that are hard to debug. The darkly humorous educational value asterisk. By intentionally creating this mess, we've highlighted the importance of asterisk avoiding global state asterisk favor dependency injection and passing data explicitly. Asterisk immutability asterisk use immutable data structures when possible to prevent unexpected side effects. Asterisk separation of concerns asterisk design classes with single, well-defined responsibilities. Asterisk avoiding side effects asterisk write functions that do what they say they do, and nothing else. Asterisk careful use of randomness asterisk use randomness sparingly and with a clear understanding of its impact. Asterisk loose coupling asterisk design classes that are independent of each other as much as possible. Asterisk descriptive error messages asterisk add more information to error messages. This twisted tutorial should serve as a cautionary tale. While it's fun to explore the dark side of programming, always strive for clean, maintainable, and predictable code in real-world projects. Unless, of course, you're deliberately trying to create a simulation of high school, then all bets are off. Good luck. And remember to keep your sanity.